So what the oblique plane will look like, let us look into this. Okay, we start with say profile, and I have got a plane, and of course because it is oblique plane it will be foreshortened in all three principal views. So one view of it on the profile, and this is the view in the frontal. Now with the help of the view in profile and on frontal, I can now generate the view or projection of this plane onto the horizontal. So let's make use of the middle line and the projectors and generate this on the horizontal plane. So here is a plane which is inclined to all three principal planes. Okay, it is oblique plane. So there will be cases like this when we have a plane like this and we are not able to get the edge view of this or normal view of the plane in on any of the principal views. But we need to determine what this plane actually looks like, what is the shape of it, what is the total area of it, okay, what is the perimeter of it. So in order to determine these quantities, we will have to project this plane onto a plane which is an auxiliary plane, as we have seen. So if there is a plane now, this is a plane which is an oblique plane, I will have to also, like in the case of the line, I will have to locate a plane which is parallel to this. So this particular plane is not parallel to the frontal, is not parallel to the profile, neither it is parallel to the horizontal. Okay, so that's why the projection of this on these three principal planes are distorted. Its projection will be true projection or normal projection only if I can project it onto a plane which is parallel to this. So like in the case of the line, here also we will do the same thing. What we will do, first of all, somehow we will identify the plane which is parallel to this. Once we have done it, we'll project this plane onto that, and then I will have the true plane. Let us see it, how we can do it. And to do this, we'll make use of one example, and in this example we'll be generating the normal view of an oblique plane. So I will be first showing you the projection of the plane on horizontal and frontal. And you know, as I have told you, once the views, I've got two views on two orthogonal principal planes, here in this case horizontal and frontal, the view of the plane on the third, that is the profile plane, profile principal plane, is now fixed. So I'm starting with these two, and let us see what the method is. So first of all, what we will do, look at this line. What this line is indicating? This line is indicating, let there is a plane and this is the oblique plane. What I'm doing, the frontal plane, I'm taking a plane which is parallel to the frontal plane, and I'm taking it in, and then I'm doing the intersection of these two. Just understand this. This is the plane which is oblique or not parallel to any of the principal planes. The very first thing that I have done, I'm taking a plane which is parallel to the frontal, bringing it here, and I'm seeing how it intersects this plane. So as you know, because this plane is parallel to the frontal, naturally the line of intersection will be also parallel to the frontal, and because the line of intersection is parallel to the frontal, the projection of that line on the horizontal will be parallel to the frontal. So this is why what I have done now, think of this concept. We are going to make use of this concept, and to do this, from a edge I have drawn a line this, and what I did, this line is parallel to the frontal. Okay, now you visualize what kind of line it is. So wherever the plane is being intersected, this line of intersection is also parallel to the frontal. Let's make use of this, and if we call this point as DH, so AD is the line now. What I do now, I bring this point D down to the frontal, and that's the DF, because you know the point D is on line BC, Okay, point D is on line BC, so the corresponding projection of the point D in frontal will be aligned with its projection onto the horizontal. That's why DH and DF are aligned through this projector. And this is why on line BFCF I could locate the point DF. Okay, so what is the characteristic of this point DF? If you join AF to DF, what is this line AF to DF? This line is nothing but, just think of that plane which was coming here intersecting, and the line of intersection was parallel to the frontal plane. So AF DF is the projection of that line of intersection onto the frontal plane, and because that line of intersection is parallel to the frontal plane, the projection AF DF is the normal view or the true length of that line, because it is being projected onto a plane which is parallel to it. Okay, we'll make use of this. So this is the true length. All right, next, so here we are writing TL as the true length. Another interesting thing, I'm writing it here, viewing along the TL, the true length, that is orthogonal to the frontal plane is the auxiliary plane A1, where edge view of the plane will be viewed. What is the meaning of that? Now, on this plane oblique, there was a line of intersection, and this line is parallel to the frontal. That's why this line is projected here with the true length. Okay. Now, what I'm saying, if I see, just think of the frontal. Okay, that's the frontal. Take another plane which is orthogonal to the frontal. Okay, which is orthogonal to the frontal, and if I look into this direction, if I from a direction, if I'm seeing the edge view of, sorry, the point view of the line, perpendicular to that will be a plane on which this line will make the point view. Okay, this line will make the point view. This is what I'm saying over here. So with the help of the true length or the projection of that onto the frontal, and then taking a plane orthogonal to the frontal, on that plane I can generate the point view of the line. Okay, so let's, and then, so again I will repeat it. This line is projected onto the frontal. I want to generate the point view of this line. To generate the point view of this line, I need to have a plane which is perpendicular to this. Okay, how will I locate that? I will look into the projection of this line onto the frontal. Okay, that's the projection of the line onto the frontal, and perpendicular to that projection and orthogonal to the frontal plane, I will locate a plane, and that's the auxiliary plane. And as this plane is coming inside, this line will project onto it as a point view. Okay, making use of this concept, that's the projector from AFDF, and I'm now looking into this direction. All right, and this is the hinge of the plane. We can call it as, say, A here or A1 here. Let's say right now we are calling it A1, though as per our definition this will be A3, the frontal will be A2, and the horizontal will be A1. In order to draw the projectors, take the distances, this is what the names will be. Okay, but the other names are horizontal, frontal, and A1. Okay, so don't confuse between these two. Okay, so our auxiliary plane A1. Now what I do, if I am looking, now this is interesting, if I am looking along that line and this line is producing the point view here, what will happen of the rest of the plane? because this line is lying on a plane, while this line is making a point view onto a plane here. So that means this entire plane will be seen as edge view over here. Okay, so if I draw the projectors and then I take the distances from here, the distance to a edge, so that from here, if it is D1, I am putting D1 here. Then if it is D2 to B, here it is D2, and it is D3 to C, here it is D3. And that is how we are locating these points. And if you join these points, this gives me the edge view of the plane. Good. Now we have the edge view of the plane, and we'll make use of this edge view further. If you go further down, so one more concept here. The concept is this. Look at this edge view. If we view perpendicular to the plane on which edge view is located, okay, we will see the true shape of the plane. I will explain it. What is the meaning of it? If you see for a plane, you see the edge view. Okay, let's say this is the plane, and we are seeing from here, we are seeing the edge view of it. Alright, so this edge view is projected on this plane. Let us say this is projected here, the edge view. In order to get true view of this plane, what I need to do? I need to draw a plane which is perpendicular to this plane where the edge view is lying. So what I will do, perpendicular orthogonal to this, I will take another plane. So now I have got another plane, and the auxiliary plane, and this is the plane. I project it here. So the projection of this plane onto the auxiliary plane created now will be the true view. Okay, so we are making use of this concept. So here also we have the edge view. What I have to do, I have to look perpendicular to this. So if I take somewhere, let's say this is the edge view, this is the edge view of a plane, and right now consider that plane is going inside the screen. That plane is going inside the screen. Okay, so on that plane I will be able to see, because I am seeing it from this direction, and over here I see the edge view. So on A1, because this entire area is A1, this entire area is A1, or this plane is A1. On A1 I see the edge view. That means under the screen, under this A1, somewhere the plane is hanging like this, so that its edge view is coming on A1. Then what I have done, I have taken a plane perpendicular to the A1. So this is the second plane which is perpendicular to the A1, because my plane ABC is hanging here, and now I have a plane perpendicular here which is hanging down again inside the screen. This plane ABC and the auxiliary plane, they are parallel, so I can project this now back to auxiliary plane. So this is what we are doing now. So let's do it. So I take the edge view of another plane, we call it A2, let's say, and then on this I will be from, now as per the definition, I will change the color to write the definition. Now at this stage what is happening, this plane as per definition is A3, this is A2, and here it is A1. So from A2 I am drawing the projectors, and I am taking the distances from A1. So these distances I will transfer to A3. Okay, D1, D2 and D3 I will transfer to A3 in order to locate the ends, the vertices of the plane. Okay, so these are the projectors. Let us do it. So I am drawing the projectors, and then taking these distances and then showing them here, so that I have the vertices of the plane known to me. So this particular view here is the normal view of the plane. Okay, so for a given plane which is inclined, which is not parallel to any of the principal planes, we could generate its normal view on the auxiliary plane. Alright, we'll make use of, in the second slide, how we can do the same thing with the help of the rotation also. Okay, so getting this by the true size or the shape of the plane by the method of rotation. Let us see how it happens. So here also, first we'll start with the projection of the plane which is known in frontal and horizontal. Okay, as in the case of the previous problem. Like in the previous case also, we are doing the same thing here. I am drawing a line which is ASDH, and this line is parallel to this, and you know what it is equivalent to, we know that. If I bring the point DH or corresponding to point D in the frontal plane, AFDF will be the true length. We have seen it. With the help of this true length, looking along this true length, I will be able to generate the S view of the plane on an auxiliary plane which is A1. So here A1 is orthogonal to F. So the condition is like this: if this is F and the plane is like this, okay, so there is another plane which is orthogonal to the frontal, okay, because that is how the plane will open. It is orthogonal to the frontal, and this plane ABC is making the S view over here. Alright, and so right now just look at this S view and the plane. So what the S view will be like this. If you draw the S view, that is how the S view will appear. Now we look for the concept. The concept is this: if somehow I can rotate this plane, right now this plane is inclined to the frontal, but I rotate this plane so that it becomes parallel to the frontal. So right now what will happen, if I am rotating this plane to make it parallel to the frontal, that means its corresponding projection is also rotating onto the auxiliary plane. Alright, so its corresponding projection is rotating onto the auxiliary plane. What is the meaning of it? The projection of the plane, or the S view of the plane on the auxiliary plane is shown over here. Okay, that's the S view of the plane. Because on rotation of this plane to make it parallel to the frontal, the S view is also rotating. Now what we'll do, we'll do the converse. What I will do, I will rotate the S view of this plane. Okay, I will rotate the S view, make it parallel to the frontal. If I do it and I then find correspondingly the plane is also rotating, so the projection of the plane on the frontal will be now true view. So what we will do now, we will rotate the S view. So let us do that. So if I rotate the S view, and we have seen also for the line the method of rotation. So this is how I am rotating S view, and let's say this is the rotated S view, and in this case the rotated S view is parallel to the frontal. Because the rotated S view on the auxiliary plane has become parallel to the frontal, that means if I correspondingly rotate the plane will be also parallel to the frontal. So the plane will project onto the frontal as normal view. So let us do this. If I do the back projection for this, as we have done in the case of the line, okay, so the point BF will shift to B dash F. Similarly, the point CF will shift to C dash F. Alright, because we know the shift will be always along the horizontal line or the line which is parallel to the hinge. So in this case, because we are doing the rotation on A1 and we are doing the projection on F, So the point will move in this line which is parallel to the A1. Okay, and that is why our point, if I show you, will always move like this, okay, along this line only. So having done this, we can find now the new locations of B dash F and C dash F. Point A is not changing, so I can generate now the projection, the new projection, or rather this AF, B dash F, AF, B dash F and C dash F, they form the normal view of the plane. So we can generate this normal view also by rotation method. Alright, we have seen now some definitions of the plane. Also for a plane which is oblique, how can we generate the true plane or the normal view of the plane on an auxiliary plane? That is what we have seen. We used both the methods. We used the method in which we did the rotation. We used the method in which we created auxiliary plane, and then we measured the distance from A1 and then took the projectors from A2, and that is how we had made the normal view on A3. So we have seen now both the methods. We'll make use of these concepts in future also. Thank you.